here what you need to remember is like what moment is. Under equilibrium, we have discussed regarding this principle of moment. Right, Mega, this is getting stuck, right? Just give me 1 second. Peradeniya. So, sorry guys, like I had connected to a different network, right? So there's few different networks. I mean, Wi-Fi is in my place, right? So like, I think I have connected the wrong one. So I guess now it would be fine, right? If it's not, please let me know. If it's worse than the previous situation, just let me know, right? Hari. So, right. අපි දැන් ඉස්සරහට යන්න. Moment concept එක පොඩ්ඩක් මම යන්න කලින් මතක් කරන්නම්. I mean, some of you guys might not remember what moment and all is. Samanning, like, you know, if you consider a certain object, right? And if it is pivoted at this point, and if you apply a force of capital F, and if the distance between this pivot and the line of action of the force is R, then of course, like, you know, due to this force, this is going to turn, right? A certain turning action is going to arise on this object, right? So this moment can be written as, right? This moment can be written as the magnitude of the force into the product between the magnitude of the force and the distance between the pivoted point and the force. Pivoted point is a force distance, simple R, right? Simple R. Right? So when the make moment, right? So this is the moment, and if a certain object is in equilibrium, right? Samanyan guys, like, so if you consider this Mudalali's balance, Mudalali's balance, right? So what happens here is when you place a certain mass, යම් කිසි mass එකක් දාපුවාම මේ පැත්තට force එකක් ඇති වෙනවා, right? Due to this weight, a certain force is going to be arised in this direction, which means this will create a clockwise moment. මෙයා clockwise moment එකක් ඇති කරනවා. හරි. මේ force එක නිසා මෙයා clockwise moment එකක් ඇති කරගෙන නිසා මෙයා මේ පැත්තට නැමෙනවා. So to balance this, අපි මේ පැත්තට weight එකක් දානවා. So because of this force, මේ pivot point එක වටේ බැලුවොත් එහෙම ඌ මේ පැත්තට moment එකක් ඇති කරනවා. So if at a certain instance this is balanced, or if at a certain instance this is in equilibrium, what that denotes is the clockwise moment has become equal to the anti-clockwise moment. So basically, when we were learning about equilibrium, we learned that if an object is in equilibrium, then the clockwise moment acting on the system is equal to the anti-clockwise moment acting on the system. If a certain object is in equilibrium, then the clockwise moment acting on the system should be equal to the anti-clockwise moment acting on the system. Basically, there should not be any net moment. There should not be any net moment acting on the system. Moment එකක් තිබ්බොත් එහෙම ඒක කැරගෙනවනේ. If there is a certain net moment on the system, it is going to rotate. It's going to turn. If it is turning, we can't say it's in equilibrium, right? So මේවා basics. මේවා මම දැන් මතක් කරනවා. Like I just reminded you guys, right? Let the මෙතනදී මම මේ theory content එක I did not do the theory content here, right? Basically, I was just reminding you guys what we have done, right? If you don't remember, so it is none of my business. If you don't remember, it's none of my business, because like I have put a lot of effort on covering the theory. I have put a lot of effort on giving you guys the paper, discussing it and all. And still, if you don't remember, it's not my mistake, right? So you have to figure it out, right? Let me move on to the experiment now. Now understand the topic first. Topic එක තේරුම් ගන්න. Try to interpret the topic first. What are they trying to say from the topic? If you are quite good at your English skills, you'll already figure it out what we are going to do. Actually, we are going to determine the mass of a certain body. යම් කිසි body එකක mass එක හොයන්නයි යන්නේ. කියන්නේ like we are going to find the mass of a certain object. We're going to find the mass of a certain object. So for that, of course, what we're going to use is the principle of moment. For that, what we're going to use is the principle of moment. Is it getting stuck? Others? Can anyone else respond and verify whether the video is clear or not? Yes, right. Why is it? Yes, I think it is related with this experiment, right? So because of all these things only, I thought of doing it a bit earlier, right? Fine. So let me first of all draw the setup. Right? Let me first of all draw the setup. No, before we go for the setup, we will have to right. Let us not go for the apparatus first. Then this is the setup, right? So you have to choose a flat surface, right? Maybe there a flat surface එකක් තෝරගන්න ඕනේ. On this flat surface, you have to place a knife edge. You have to place a knife edge. Now, you might wonder what this knife edge is. Knife edge එකක් කියන්නේ මොකක්ද කියලා you'll wonder. Right? Knife edge. In Sinhala, we call it as pihidaraya. We call it as pihidaraya. So, basically, knife edge is something like this. Like, have you seen this kind of a thing? Wedge එකක් වගේ. Wedge එකක් වගේ. This is a sharp point. It's like a pyramid. Right? Knife edge. These things are there in your school labs. Right? So you place the knife edge first, right? On this flat surface. Fine. Next, what you have to do is right. Next, what you have to do is you have to place a meter ruler on this knife edge. You have to place a meter ruler on this knife edge. Right. So let me place a meter ruler on this knife edge. Right. Actually, placing a meter ruler is not what is actually required. What actually required is balancing a meter ruler on the knife edge. අපි knife edge එක උඩ meter ruler එකක් balance කරන්න ඕනේ. We have to balance a meter ruler on the knife edge. මේ knife edge එක උඩ මේ meter ruler එක balance කරන්න ඕනේ. Why do we balance it? So you'll have a lot of questions, right? So all these things will be answered under the important facts regarding the experiment. Right. So we have to balance it. Fine. So now let us assume the meter ruler is balanced. Now let us assume the meter ruler is balanced on the knife edge. Balance එකේ තියෙනවා. කොයි පැත්තටත් වැනෙන්නේ නැහැ, balance එකේ තියෙනවා. The next thing what you have to do is you have to take two masses. One is a known mass of around 50 grams. Right? You have to take a known mass of around 50 grams. Correct. And then you have to connect it and then you have to connect it to this side, left side. Let's assume the mass of it is m naught. You don't have to specifically take 50 grams. But school lab එකේ කරද්දී නිකන් 50 grams වගේ ගන්න ප්‍රශ්නයක් නැහැ. So you don't have to specifically take 50 grams, right? I mean, මොකක් හරි දන්න mass එකක් ගන්න ඕනේ. ඔය scale pans වල දානවනේ තරාදි පඩි. You know, we call them as standard weights, right? Standard weights. So these standard weights, take one of these standard weight, right? Maybe it should be around 50 grams, like, and then connect it to one end. Connect it to one end. And after connecting it to one end, next what you have to do is, now actually we are performing this experiment. Why, guys? In order to determine the mass of a certain body. We are actually performing this experiment to determine the mass of a certain body. So therefore, next what you have to do is, ara mass එක සෙවිය යුතු body එක ගන්න. Next what you have to do is, like, you have to take the mass, you have to take the body, or you have to take the object whose mass is supposed to be found. And then you should hang it from here. You should hang it on the other side. Let me assume that mass is simple length. Let me assume that mass is simple length. Now, as the next step, what you have to do is, you have to measure this length. I mean, length to this string from the knife edge. Let's assume it is y, and the length to this string from the knife edge, let's assume that is x. I mean, I think I forgot to mention one thing, right? The meava y කියන like some යම් කිසි තැනකින් mark fix කරගත්තනේ. මෙයාවත් යම් කිසි තැනකින් fix කරගන්න. So as soon as this is fixed in this way, will it be balanced? Fix කරපු ගමන් මම දෙන්න මේ one shot balance විදියට ඉන්නවනේ. කිසි පැත්තකට පාත් වෙන්නේ නැතුව ඔහොම කෙලිම balance එක ඉන්නවා. No. It is not going to be in balance, or else like it's not going to be in equilibrium as soon as we fix it. As soon as we fix it, it is going to, you know, bend towards a certain direction. We don't know what. It depends. එක්ක මේ පැත්තට නමෙන්න පුළුවන් නැත්නම් මේ පැත්තට නමෙන්න පුළුවන්. It depends. Somehow it's not going to be in equilibrium at the initial instance. When I do an experiment, you have to visually you know, try to create all these things in your mind, right? Visual image එකක් හදා ගන්න ඕනේ, right? So I can't take you guys to a laboratory and conduct these experiments, right? So like that is not how things were done actually, right? When you get the opportunity, when you go to schools, like when you get the chance, you can do these experiments, but that's not a compulsory thing, right? I mean, like all these, years, not everyone has had the opportunity to do experiments in the school labs, but still most of them got very high results and got through, right? So even myself, if you consider, like I did very less practicals, right? Practicals like මම ඉස්කෝලේ අන්තිම exam එකට ඔය සති 3-4ක් විතර තියෙද්දි permission අරගෙන ගිහිල්ලා එක දිගට ඔක්කොම experiments ටික ඉස්කෝලේ කරලා දාලා ආවා. So other than that, of course, like we also didn't have the chance to do the experiments much. But if you had the chance, if you do get the chance, utilize it. But it's not a compulsory thing, right? So therefore, like when I teach you on the board, I'll try to somehow maximally create the image in your mind. So you'll have to try to visualize it, right? So whether ගහපු ගමන් මේක balance එකේ තියෙන්නේ නැහැ. So it's going to bend in a certain direction. So in order to balance it, what do you have to do? In order to balance it, what do you have to do? You have to change the positions, right? You have to change the position of this y. X කියන එක fix තියාගෙන මේ y කියන එක වෙනස් කරන්න. පොඩ්ඩක් එහාට ගන්න. බලන්න balance වෙනවද? නෑ. balance වෙන්නේ නෑ. ඒතකොට තව පොඩ්ඩක් මෙහාට ගන්න. අතන පොඩ්ඩක් balance වෙන්න වගේ යනවා. එතකොට තව පොඩ්ඩක් චූඩි මෙහාට අරගෙන, like I mean you have to change the position of, or else I mean simply you have to change the y distance. You have to change the y distance and you have to get the balance. Y distance එක change කරලා ඔයා balance එක ගන්න ඕනේ. හරි. So now let us assume the two are now perfectly in balance, which means the system is in equilibrium. What does that denote? If the two masses are in proper balance, and if this is horizontal, make a horizontal තියෙනවා නම්, මෙන්න මේ meter rule එක horizontal තියෙනවා නම්, what that means is that the system is in equilibrium. So why, like there's a question, why can't we change the x distance? Yes, that's a good question, but let me not answer that right away. Right. Let me go further. And while we go further, let me explain that as well. Right. Hurry. Fine. Now we have balanced it. So if the system is in equilibrium, what does that mean, guys? If the system is in equilibrium, what does that mean? That means that the vertical, there is no net vertical force. There is no net horizontal force. There is no net resultant moment acting on the system, which means anti-clockwise moment is equal to the clockwise moment. මම මේ point එක G කියලා ගන්නවා. So G වටේ moment එකක් ගත්තොත් එහෙම the weight of this is mg. So force is mg. From G, I mean, actually what should happen is, like, since the system is in equilibrium, system එක equilibrium එකේ තියෙන නිසා G වටේ, or else like ඕනම point එකක් වටේ, the clockwise moment should be equal to the anti-clockwise moment. So මම G කියන point එක consider කරනවා. එතකොට G point එක වටේ clockwise moment should be equal to the anti-clockwise moment. Right? So what is the clockwise moment? How do you write the magnitude of the clockwise moment? Help me now. How do I write this clockwise moment? How do I write the clockwise moment? How do I write the clockwise moment? Clockwise moment is written. What is the force acting? The force acting is mg. What is the perpendicular distance between this line of action and the point of pivot? mg into x. Is there any other clockwise moments around g? Is there any other moments around, I mean, clockwise moments around g? No. So this clockwise moment should be equal to what? Since the system is in equilibrium, this clockwise moment should be equal to the anti-clockwise moment. Now, can you give me the expression for the anti-clockwise moment? How do I write the anti-clockwise moment? G vate had an anti-clockwise moment. This m naught, because of this m naught mass, there's going to be a m naught weight. m naught g weight එකක් පහලට ක්‍රියා කරනෝනේ. ඒතර මේ force එක නිසා මේ පැත්තට anti-clockwise moment එකක් ඇති වෙනවා. So how do we write this anti-clockwise moment? Force into perpendicular distance y. So basically, if you can't write this expression, or if you can't understand this expression, that means you are not up to the standards of moment principle. Moment principle එක සම්බන්ධව දැනගන්න අවශ්‍ය යුතු දේවල් තාමවත් දන්නේ නැහැ. Right? So therefore, you have to be humble enough to once again revise the theory that you have already learned. මතක නැත්තම් revise කරගන්න. Not late yet. තාම පරක්කු නැහැ. Right? So, right. Here, of course, you can cut this g to g. Right? So, what is the unknown mass? Moon, simple m unknown. So, m is equal to what? M naught y over x. So, you know, guys, this m naught is the known mass. M is the unknown mass. M is the unknown mass. X, you can measure it, right? This is a meter ruler. Since this is a meter ruler, you can measure the distance x. Right? X කියන එක measure කරන්න පුළුවන්. M naught අපි දන්නවා. Known mass එකක්. Y කියන එකත් measure කරගන්න පුළුවන්. Because this is a meter ruler. මේ දුර හොයාගන්න පුළුවන්. So simple m can be found. Yeah, tension is going to get cancelled, right? Because tension is a mutual force. මෙතන පහළට tension එක, මේ tension එකට කැපෙනවා. So the system එකේ ඉතුරු වෙන්නේ මේ force විතරයි. Right. So up to this point, was it clear? That's not clear, please ask. I don't feel bad, like ask. Right. Right. So, right, that's done. Now, this is not the experiment. I mean, yes, this is how you determine the mass. But actually, in physics, we do not determine the answer just using one set of reading. මෙතන readings මොකක්ද අපිට? මේ එක්ස්පෙරිමන්ට් එකෙන් අපිට හම් වෙන රීඩින්ග්ස් මොනවාද? This x distance and this y distance. Right? So what are the readings that we obtain from this experiment? This is so basically by just one set of reading, we usually do not determine the answer in physics. If we are going to get the answer by just one set of reading, we don't call it as an experiment, right? Because the value that we get from an experiment should be, generally it should be a pretty good average value. It should be a pretty good accurate value. So what are the reasons why we don't go with one set of reading? I mean, එකපාරට right දැම්මා මේ පැත්තේ දැම්මා මේ පැත්තේ දැම්මා x measure කරා මේ balance කරාට පස්සේ x measure කරා y measure කරා x මෙතන දැම්මා y මෙතනට දැම්මා ඊට පස්සේ m note එක දැම්මා m. Why don't we do that? One possible reason is හිතන්න, when measuring either x or when measuring either y, you made a mistake. You made a certain mistake. Because these are practicals, right? You made a mistake. If you make a mistake, your final value that you get for the mass is also going to be a completely mistaken answer. So we can't afford to get such a mistaken value. Yes, this would rarely happen, but still, we don't take chances in physics. We don't take chances in such experiments. So therefore there is a good practice, that is to get an average value for this mass. මේ mass එකට මේ m කියන value එකට අපි average value එකක් ගන්නවා. How do we get that? We have to repeat this same procedure around 6 times. We have to get around six readings. We have to plot a graph. We have to get the simple m using the graph. How are we going to do that? That's what we are going to see next. But before going for that, up to this part, let us put down the note. Nathang, it's going to be overloaded, right? So overloaded na puluwa. සම්පූර්ණ experiment එක කතා කරලා ඉවර කරලා note එක දාන්න ගියොත් it's going to be overloaded. So therefore, like, let me give you the content, procedure, and then අපි ඉස්සරහට යන්න. පොඩ්ඩ ඉස්සරහට යන්න. හරිද? Right. While writing also, please try to think about it, right? ඇයි මෙහෙම කරන්නේ? ඇයි අපිට මෙහෙම කරන්න තිබ්බනේ? ඇයි කල්පනා කරන්න. Most of your answers, most of your questions will be answered under the important facts regarding the experiments, right? Fine. So write down the subtopic and draw this figure, guys. Don't go to write this values. මේ expression එක ලියන්න එපා. මේ equation එක එහෙම ලියන්න එපා. මේක ලිව්වා, මේ figure එක ගන්න මේ ටික දාගත්තා. මෙන්න මේ ටික. එච්චරයි. Quickly. Is it done, guys? Right. So write down the procedure. Write down the procedure. Balance the meter ruler. Balance the meter ruler on the knife edge as shown in the figure. Within bracket, write down. It is better to mark the balancing point position. It is better to mark this balancing position with a pencil. Next point. Choose a weight. Choose a weight within bracket from the weight box. From the weight box. Close bracket, which is roughly same as that of the unknown mass. Next point. Hang the unknown mass. Hang the unknown mass by the ruler. By the ruler with a piece of string. Next point. Then hang the known mass by a string. Then hang the known mass by a string on the other side from the knife edge. From the other side of the knife edge. Next point. Next, adjust the position of the known mass to balance the meter ruler again on the knife edge. Then measure, next point, then measure the distances. Then measure the distances to the position of the known mass and the unknown mass from the knife edge. And can you take these things down? Meeting the lines thing. Right. Now, guys, we discussed that we don't generally find the answer by just using one set of reading, y සහ x. දැන් මෙතනදී experiment එකෙන් අපි මේ ඇත්තටම what do we get? We get the x value and the y value. So those are the two readings that we measure from this experiment. But using these two readings only, we don't generally find the answer because sometimes it can be incorrect. Due to mistakes that might happen, sometimes it can be incorrect. Sometimes is also unacceptable. Some of you guys might argue, so okay, I think it's a local දෙයක් නෙමෙයි සාමාන්‍යයෙන් අපිට පොඩ්ඩක් පිළිවෙලට කරොත් එහෙම x and y ලේසියෙන් හොයාගන්න පුළුවන්. Yes, that is true, but as a habit, so this is a normal easy experiment. But in the future, you will go to more complex experiment, more complex procedures. So as a habit, we don't do that. We don't find the answer by using just one set of reading, right? The මේක ආයෙ ඉස්සරහට repeat කරන්නේ නැහැ, right? ඉස්සරහට ගොඩක් experiments අපි කරනවා. ඒක experiment එකක හරි අපි මේ එක set of reading එකකින් values ගන්නෙ නැහැ. So don't expect me to explain this once again, right? At that point of time, ඇයි අපි ගන්නෙ නැත්තේ? This and that, right? So the method is you have to rearrange this. මේක rearrange කරගන්න මෙන්න මෙහෙම. Y is equal to m over m naught වරක් x. Y is මට තප්පරයක් දෙන්න. Certain parallel batchmate of mine has passed away because of this pneumonia, right? So like, I'll drop text and come. Right, guys, may just a simple advice, right? ලෙඩ මොකක් හරි ඕක තියෙනවා නම් ඔය තියාගෙන පරණ වෙනකන් ඉන්න එපා, guys, right? So like, let me give you a basic. I mean, actually, what happened was like there was a friend of mine, right? Like, actually, he's a parallel batchmate of mine, right? Again, while I was at the university, right for actually like අපේ degree එක අවුරුදු 4යිනේ medicine අවුරුදු 5යි so like that student that guy is that friend of mine is also still in the university හරිද his final year හෙට නිතර pass out in 80 හරිද Peradeniya university medical faculty right doctor කෙනෙක් වෙන්න ඔන්න මෙන්න doctor කෙනෙක් වෙන්න ඔන්න මෙන්න හරිද so actually what happened was guys right මෙයාට common cold එකක් තිබිලා තියෙනවා හරිද common cold එකක් තිබිලා තියෙනවා සාමාන්‍යයෙන් අපි කවුරුත් වැඩි ගණන් ගන්න නැහැ නේ common cold එක හරි but මෙයාට පොඩ්ඩක් උග්‍ර වෙලා තියෙනවා ඒ common cold එක පොඩ්ඩක් උග්‍ර වෙලා තියෙනවා පොඩ්ඩක් එයාට pneumonia වගේ කලිනුත් කොහොම ඇවිල්ලා ඔය symptoms තිබිලා තියෙනවා but he's a doctor we should know these things right එතකොට like එයාට මෙන්න මෙයාට මේ common cold එක අර ටිකක් severe වෙන අවස්ථාවේදී උනා එයා පැනඩෝල් ගහලා ක්ලිනිකල්ස් යනවලු හරිද පැනඩෝල් ගහලා ක්ලිනිකල්ස් යනවා because ක්ලිනිකල් මිස් වුණොත් එහෙනම් බැච් මිස් වෙනවා හරිද දැන් හොස්පිටල් ගිහිල්ලා අර ක්ලිනිකල් ප්‍රොසීජර්ස් වගේක් කරන්න තියෙනවා මෙඩිකල් ස්ටුඩන්ට්ස්ලාට ඔවා මිස් වුණොත් එහෙනම් බැච් මිස් වෙනවා ඒක ක්ලිනිකල් ප්‍රොසීජර්ස් කරන්න සහ ඔය එයාට එක්සෑම්ස් වගේක් තිබිලා තියෙනවා ඒ එක්සෑම්ස් අර මේ එහෙම what attend කරන්න ඕන නිසා මෙයා මොකද්ද කරලා තියෙන්නේ මෙයාලා පැනඩෝල් ගහලා දිගටම පැනඩෝල් ගහලා අර ඒක සර්ප්‍රෙස් කරගෙන තියාගෙන ඉඳලා pneumonia කියන condition එක එයා suppress කරලා ඒක ඇතුළේම suppress කරලා තියාගෙන so at a certain instance what has happened is like while he was performing a certain clinical process he has fainted right he has fainted and then he was admitted to the hospital like hospital එකම තමයි හිටියේ හරිද hospital එකම තමයි හිටියා like he was admitted and then you know what happened was like after around being in the ICU for 1 month right මාසයක් විතර ICU එකේ මෙඩිකල් ස්ටුඩන්ට් කෙනෙක් හරිද ෆයිනල් ඉයර් හෙට නිතර පාස් අවුට් වෙන්න ඉන්නවා කියලා කිව්වම ඔයා හිතලා බලන්න පෙරදින යුනිවර්සිටි එකෙන් පෙරදිනිය මේ පෙරදින හොස්පිටල් එකෙන් ඒ ළමයාට එයාට දුන්න කෙයා එක වගේ හිස්ටරි එකේම කාටවත් එච්චර කෙයා එකක් දීලා නැහැ right I mean everyone was praying for him right I mean like you know just now I got the message that he passed away right that much of care intense care was given right like if it was some other person right වෙන යම් කිසි පුද්ගලයෙක් නම් ටිකක් වයසක පුද්ගලයෙක් නම් already he might have passed away like long time back right I mean එච්චර care එකක් දෙන්නේ නැහැ සාමාන්‍යයෙන් දෙන්න බෑනේ තියෙන resources එක්ක right එක්කෙනෙක්ට හැමදේම දීලා තියාගන්න බෑ like ventilators දීලා හැමදේම දීලා like they were trying to you know cure him but unfortunately ended in this way like it's really sad situation but to do right like life should go on and that's how it is isn't it so just a piece of advice right like don't you know if you have any problems health related problems right please either take proper medications or else like you know be little concerned right so it doesn't matter whether it's a common cold or whatever it is things could go serious unintentionally unknowingly right so yes right so let us pray for him right right all good fine let's get back to the lesson right tell about right what their parents would have been feeling right a doctor he was supposed to marry this December and he's almost passed out right doctor කෙනෙක් විදියට එළියට එන්න ඔන්න මෙන්න තව මාස දෙකයි තිබ්බ මෙන්න ඩිසෙම්බර් ඉවරයි යාළුවන්ට that's how life that's how unfair life is right Hari, let us move on right what we did was I just basically rearranged this expression guys what I did was I subjected y x කෙනෙක් මේ පැත්තට multiply කරා m note එක යනට ගත්තා හරිද so this is similar to a y equal mx graph y equals mx graph so here what is the x variable x variable එක අපිට සාමාන්‍යයෙන් x variable එකට what do we call the x variable as? We call the x variable as the independent variable. අපි x variable එකට සාමාන්‍යයෙන් කියන්නේ independent variable එක කියලා. y variable එකට අපි කියන්නේ dependent variable එක කියලා. Why? Because y depends on x. අපි x වෙනස් කරොත් ඒත් එක්කම y වෙනස් වෙනවා. So what you have to do is basically, guys, right? So you performed one experiment, right? One set of reading you obtained, right? X වලටයි y වලටයි එක set of reading එකක් ඔයා ගත්තා දැන්. Right? X එක y එක ගත්තා. Next what you have to do is you slightly change this x value. අපි හිතමු පොඩ්ඩක් වැඩි කරන්න. x කියන එක පොඩ්ඩක් වැඩි කරන්න. When you increase x value, what will happen? The balance is going to break. Balance is going to break කියන්නේ අර මේ balance එක නැති වෙනවා. කලින් අපි balance කරලානේ තිබ්බේ. x එකටයි y එකටයි. x එකටයි y එකටයි කලින් balance කරලා තිබ්බේ. දැන් ඔයා x කියන එක පොඩ්ඩක් වැඩි කරන්න. මෙන්න මේක චූට්ටක් මෙහා පැත්තට ගෙන්න. එතකොට මේ පැත්තට බර වැඩි වෙනවා. නැමෙනවා. මේ පැත්තට නැමෙනවා. So ඒක balance කරන්න what you have to do is you have to move this y also little that side. මෙන්න මේ y කියන එකත් චුට්ටක් increase කරන්න ඕනේ. ඒකත් පොඩ්ඩක් increase කරමුකෝ මම අන්න ආපහු balance එකට එනවා. Right. So you measure the new x value and the new y value, right? ආයක x2 y2 කියලා දාගන්න. x2 y2 කියලා දාගන්න. ඊටසේ තව එකක්. තව පොඩ්ඩක් x වැඩි කරන්න. එතකොට y වැඩි කරන්න වෙනවා. balance එක තියාගන්න නම්. එතකොට ඒක x3 y3. ඔය විදිහට x4 y4 x5 y5. ඔය විදිහට around 5 set of readings අරගන්න. Around 5 set of readings අරගන්න. හරි. You take around 5 set of readings. Now what you have to do is you have to plot this in a graph. You take a graph paper, මේක x axis එක, මේක y axis එක. එතකොට මේ xy y1 x1 y1 මේ වගේ තැනකින් එන්නේ. x2 y2 x2 y2 මේ වගේ තැනකින්. x3 y3 x3 y3 මේ වගේ තැනකින්. x4 x4 y4 මේ වගේ තැනකින්. x5 x5 y5 මේ වගේ තැනකින්. So you connect these, finally you connect these lines. So when you connect these lines, according to this expression, you should get a straight line which goes through the origin. You will get a straight line that goes through the origin. Will get a straight line that goes through the origin. So, I mean, there's a question, can't we decrease x and y value? Yes, you can do that, right? There's no issue in that. But I mean, generally, like when we perform an experiment, we prefer more. That is the standards, right? But still, like even if you decrease, like y will also decrease. You get, I mean, there's no issue, right? Like the same. Hurry. Then graph fact ගෙහුවා. Now what? The graph එක ගහන එක නෙමෙයිනේ අපේ goal එක. Our goal is not to grow the graph, right? Graph වන්දිනේව නෙමෙයිනේ, like our goal was, what was our goal? Our goal was to find the unknown mass. මේ unknown mass එකේ value එක හොයන එක තමයි අපේ goal එක. So next what you have to do is, from this graph you measure the gradient. මේ graph එකේ gradient එක measure කරන්න. දැන් gradient එක මොකක්ද කියලා මගෙන් අහන්න එපා. Why? Because you all did A levels, නෙමෙයි O levels කරලා තමයි මෙතනට ආවේ. Right? Almost all of you guys did your, all of you guys නෙමෙයි හැමෝම, almost නෙමෙයි everyone did your O levels and came here. So you should know what gradient is. Gradient කියලා කියන්නේ මොකද්ද? මේ graph එකේ inclination එක. මේ graph එකේ inclination. How do you measure the gradient? How do you measure the gradient? How do you measure the gradient? මේකෙන් මේක අඩු කරන්න. Right? I mean gradient එක ගන්න කොහොමද? මේකෙන් මේක මේ දුර delta y නම් මේ දුර delta x නම් gradient එක ගන්න කොහොමද guys? Gradient is equal to delta y opposite over adjacent. Opposite over adjacent. y2 minus y1 x2 minus x1 මතකද? මතකද tan theta? ඉස්සර කරානේ අර ඔය කාලේ මොකද්ද? y2 minus y1 x2 minus x1 අර. So අර gradient එක හොයාගන්න right. Now you have found the gradient. අපි හිතමු gradient එක හොයාගත්තා. So gradient කියලා කියන්නේ මොකද්ද? මම මේක m dash කියලා කියන්නම් හරිද? නැත්නම් මේ m dash එක මේ m එකත් එක්ක පැටලෙනවා. So now you can see the gradient is equal to this. Gradient is equal to what? Gradient is equal to mo m naught. මේ expression එක මේක එක වගේනේ. So you can see this gradient is equal to mo m naught. Now we have found the gradient. අපි gradient එක හොයාගත්තා. graph එකෙන් gradient එක හොයාගත්තා. m naught අපි already දන්නවා. So can't we find simple m? We can. මෙතනදී simple m ට එන value එක it is going to be a very much of an average value. දඩ average value එකක් එන්නේ. ඇයි ඒ? readings පහක average එක එන්නේ මෙතන simple m. readings පහක් ගහලානේ අපි gradient එක ගත්තේ. ඉතින් මේ gradient එකට එන value එක පට්ට දඩ superior උත්තරයක් එන්නේ gradient එකට. The value that you are going to get for the gradient is going to be pretty much of a very accurate answer. m naught already known. මේ දෙක multiply කරපු ගමන් ඔයාට maths එක easy හම්බ වෙනවා. maths එක easy හම්බ වෙනවා. I'll once again say what we did. Guys, we don't find the answer by using one set of readings. So therefore we have to perform the experiment several times and we have to obtain minimum around 5 to 6 set of readings and then only we have to get the answer, right? So to get to get 5 to 6 set of readings, we need to have an independent variable and we need to have a dependent variable. Independent means like we have to change something and as a result of that something should be changed. එතකොට අපි මේ මොකද කරන්නේ? අපි x කියන එක පොඩ්ඩක් වැඩි කරනවා. So balance එක නැති වෙනවා. So ආයෙ balance එක ගන්න y ටිකක් වැඩි කරන්න වෙනවා. එතකොට another set of readings ගන්නවා. balance කරාට පස්සේ x2 y2 ගන්නවා. ඒ විදිහටම ආපහු x තව පොඩ්ඩක් වැඩි කරලා x3 y3 ගන්නවා. ඒ විදිහට 5 set of readings ගන්නවා. So if you rearrange this expression, you'll get y equal mo m naught x. This is similar to what? This is similar to y equal mx. Y equal mx graph. Y equal mx graph කියලා කියන්නේ a graph, a straight line which goes through the origin. Y equal mx plus c කියලා කියන්නේ a graph which has an intercept. A straight line which has an intercept. Right? ඕවා මතක නැත්තම් නම් පුතා මට කරන්න මේක අමාරුයි. Because මේ වගේ තැන්වල මේවා තේරුම් ගන්න තමයි like ඔයාලට O levels වලදී ඔවා කියලා දෙන්නේ. You know. So you need to remember the y equal mx plus c form, right? Straight line form. මතක නැත්නම් ඒවා revise කරගන්න. YouTube හරි බලන්න. Like I can't teach mathematics right now, right? So this is similar to a straight line which goes through the origin. Origin එක කරා යන straight line එකකට මේක සමානයි. So like මේවා plot කරන්න. And then you draw the graph. Graph එක ඇඳලා graph එකේ gradient එක ගන්න. Gradient එක ගන්න කොහොමද? Opposite over adjacent. Gradient එක සමානයි opposite over adjacent. එතකොට මේ දෙක compare කරලා බලුවොත් එහෙම gradient එක සමානයි mo m naught. Gradient එක සමානයි mo m naught. Gradient එක දන්නවා. අපි හොයාගත්තා m naught දන්නවා. So m කියන එක ලේසියෙන් හොයාගන්න පුළුවන්. So that is how we get a very accurate value for the unknown mass. Was that clear? Right? Great. Which means we can go on to the note. ලියා ගන්න. generally, the value that is supposed to be found, generally, that is supposed to be done, I mean, generally, what is supposed to be found is not calculated, simply by one set of reading. Instead, to get a better average value, it is not, I mean, to get a better average value, repeat the experiment 4 to 5 times. Repeat the experiment 4 to 5 times, and repeat the experiment 4 to 5 times by increasing, by changing the x distance, by changing the x distance. And then plot the graph, and find the unknown using the gradient of the graph, as below. Right? Can you මෙහෙම දාගන්න, මේක මේ විදිහට දාගන්න. හරිද? අහගන්න. මුලින්ම ටැබියුලේට් කරගන්න. මෙන්න මේ ටේබල් එක අරගෙන ඊට පස්සේ මේක දාගන්න. හරිද? නැත්තම් මේ ඔව් මේක දාගෙන ඊට පස්සේ graph එක දාලා මෙන්න මේ ටික දාගන්න. හරිද? Is it done, guys? Right. Fine. Now we will go for the important facts regarding the experiment, right? Important facts regarding the experiment. Write down the subtopic. Write down subtopic. හරිද? දැන් මම එකින් එක කියාගෙන යනවා. Like we will be discussing one point. We're gonna write the note. We're gonna discuss the second point. We're gonna write the note. In that way, we're gonna proceed further. Hari. First thing. පළවෙනි දේ. Let me ask you a question. What is the reason to balance the ruler prior to hanging the weights? Weight hang කරන්නත් කලින් why do we balance the meter ruler? Like you can give me your opinions. We can, I mean, no one is going to judge here, right? Why do you think we need to balance the meter ruler even before hanging the weights? The reason is this. If we balance the meter ruler, like meter ruler එක balance කරනවා කියලා කියන්නේ අපි මොකද්ද? meter ruler එක balance කරනවා කියලා කියන්නේ meter ruler එක balance වෙන්නේ මොන අවස්ථාවේදීද? Only when the weight of the meter ruler falls on this knife edge. When the weight of this meter ruler exactly falls on the knife edge, then of course මේ knife edge එක වටේ මේ පැත්තට moment එකකුත් නැහැ, මේ පැත්තට moment එකකුත් නැහැ, which means it's going to be in balance. බැරි වෙලාවත් ඔයා එහෙම තියන්න නැතුව මෙහෙම තිබ්බොත් එහෙම බලන්න මොකද වෙන්නේ කියලා. දැන් හිතන්න මේ අවස්ථාවේ ඒතර මෙතන තමයි weight එක තියෙන්නේ. So මේ G කියන point එක වටේ මේ පැත්තට moment එකක් ඇති වෙනවනේ. මේ G කියන point එක වටේ අර පැත්තට moment එකක් ඇති වෙනවා. So as a result of that, it will topple to that side. ඒක අර පැත්තට topple වෙනවා. So මෙයා අපිට balance කරන්න අනිවාර්යයෙන්ම වෙනවා. So why do we balance the meter ruler? We balance the meter ruler, then only this weight will not come into the equation. මේ ඇත්තටම මෙතන weight කියන එකක් තියෙනවා. මේක මෙතනින් යනවා. ඇත්තටම මේ ruler එකට weight එකක් තියෙනවා. ඒක හරියටම අර G කියන point එකකින් යනවා. එතකොට අර when we apply moment around G, this WG is not going to affect this equation. G එක වටේ moment එක දානකොට WG බලපානවද? නෑනේ. Because G point එක හරහා මේ WG යනවනේ. Then of course the moment due to this WG is going to be 0. එතකොට අර මෙන්න මේ moment equation එකට එයා එන්නේ නැහැ. එතකොට වැඩේ ලේසි අපිට. නැත්තම් වාවොත් එහෙම ආයෙ එන කෙලියක් වෙනවා. ආයෙ උගේ moment එකක් ගන්න දෙපෑ. වාව කියලා කියන්නකෝ. එතකොට මේ moment due to this guy, moment due to the weight එන කෙලියක් වෙනවා. equation එක දිග්ගැස් වෙනවා. So it's difficult. So basically, why do we initially balance the ruler even before adding the weights? Mainly, this is done to avoid the weight of the ruler getting into our experiment or getting into our moment equation. To avoid the weight equation to avoid the weight by getting into our moment equation. That's the basic thing, right? So let us put this number 1. Let's put the first point. The main reason to balance the ruler prior to hanging weights is since the ruler is balanced at its center of gravity, the experiment is unaffected by the weight of the ruler. The experiment is unaffected by the weight of the ruler, right? I will repeat. The main reason to balance the ruler prior to hanging weights is since the ruler is balanced at its center of gravity, the experiment is unaffected by the weight of the ruler. Right. Now next thing. So the point 2. You guys might not have noted it, right? You might not have noted it. But while I was giving you the description for the procedure එක ගැන මම ඔයාලට description එකක් දෙනකොට I specifically mentioned that when you choose the standard mass, this standard mass should be somewhat closer to the weight range of this unknown mass. තේරුණා ඒක? හිතන්න unknown mass එක ඇත්තටම it's in the range of 50 kilograms කිට්ටුව වගේ, 50 grams කිට්ටුව වගේ. එතකොට ඔයා තෝරන්න ඕනේ, ඒ කියන්නේ standard weight එක විදියට ඔයා ගන්න ඕනේ 50 grams. හිතන්න මුගේ grams 200කට කිට්ටුව මේක අපි හිතමු the unknown mass is something closer to 200 grams. So when this unknown mass is something closer to 200 grams, you can't choose 50 grams as the standard mass. ඇයි එහෙම වුණාම වෙන්නේ මෙයා hang කරනවා. එතකොට මේ weight එක balance කරන්න මේ moment එක balance කරන්න අර 50 grams කියන එක්කෙනාව ඔයා සෑහෙන ඈතින් තියන්න වෙනවා. මේ 200 gram කියන unknown mass එක ඇති කරන මේ moment එක clockwise moment එක balance කරන්න ඔයා ඒක balance කරන්නේ anti clockwise moment එකකින් මේ move hang කරලානේ. ඒතර move ඔයා සෑහෙන ඈත තියන්න වෙනවා. එතකොට තමයි balance කරන්න පුළුවන් වෙන්නේ. But can you go to very longer distances? No, because you have a very limited space to go. So when you choose the standard mass, the standard mass should be somewhere closer to the range of this unknown mass. Mu 200 gram නම් ඒ කියන්නේ mu 200 gram වලට කිට්ටුව නම් ඉන්නේ. මුවත් 200 gram වලට කිට්ටුව ස්ටෑන්ඩඩ් මෑස් එකක් තෝරන්න 190 හරි 180 හරි 220 හරි මොකක් හරි ස්ටෑන්ඩඩ් නෝන් මෑස් එකක් තෝරන්න like closer to this range. එතකොට තමයි මෙන්න මේ distances shape වෙන්නේ. එතකොට තමයි මේ එක ළඟ distances එන්නේ වාට. mu 200යි අරු 10යි. mu 200යි unknown එක 200යි. අරුව තෝරගන්නවා 10යි. එතකොට ඔයාට බැලන්ස් කරන්න බෑ. ඒතකොට බැලන්ස් කරනවා එන්න දුර අරන් යන්න ඕන. ඒතකොට අර completely different distance ranges you get. It's going to be a problem when performing an experiment like that. So we preferably don't do that. We usually go with, I mean, you don't know the unknown, you don't know the mass of the unknown object, but you should be able to guess the range, right? සාමාන්‍යයෙන් ගල් කැටයක බර වාට guess කරගන්න පුළුවන්. මේක 200 grams ද නැත්නම් it's purely assumption, right? I'm not going to ask you to exactly determine, right? You don't have these magical powers to decide what it is before you measure itself, right? Weight එක measure කරන්නත් කලින් වාට කියන්න බෑනේ. Like you have to make, I mean, an assumption in what range the unknown mass is going to be. Actually, you can මගේ weight එක මාව බලපුවම වාට කියන්න පුළුවන්. like මම nearly 70 kilograms කියලා කියන්න පුළුවන්, right? So basically, if you see this pen, of course you can make an assumption. Make a 10 grams වගේ කියලා. So ඒ කිට්ටුව යන්න ඕන. හරිද? මේක balance කරන්න කිලෝ 10ක් මෙතනින් ගෙනල්ලා ගහන්න නෑනේ. ඒක balance කරන්න බෑනේ. It's not possible නේ. I mean, you just have to use the standard mass somewhat closer to the unknown mass, right? හරි. ඒක දාගන්න. ලියගන්න. Generally the standard mass should be chosen somewhat closer to the range of the unknown mass, right? Guys, there are around 4 to 5 more points, right? There are around 4 to 5 more points. I have to leisurely do it, right? මම ඕක ඊළඟ අපේ theory class එකේ මුලින්ම I'll take around 15 minutes to discuss these points, and then thereafter only I'll be going into the theory of Pascal law, right? Pascal principle එකට යන්න ඊට පස්සේ, right? I have some meeting to attend at around 9:45. I have to have my dinner and go to that meeting, right? So I'll do the rest of the continuation on the theory class. So we have almost completed the experiment. Our points හතරක් විතර තියෙනවා. ඒ ටික මම leisurely කියන මම හදිස්සියෙ මම දැන් කියන්න ගත්තොත් එහෙම like I know I'll be not giving you guys my maximum, right? So therefore let me do it on the next class. So there's a question. Let me finish after the question. Why don't we change the x distance? Reminder. Why don't we change the x distance? So x distance is the independent variable. So මෙතනදී ඔයා x වල වෙනස් කරන්නේ. x ඔයා හිතන ගානක් දානවා. දාලා මේක balance කරන්න මෙහෙන් හදනවා. Because there should always be an independent variable and a dependent variable. There should always be an independent variable and a dependent variable, right? Actually, even if you interchange this x and y, it is not going to be an issue, right? ඔයා මේ x and y interchange කරලා බලන්න. x and y interchange කරාම මේ වෙන්නේ ඇවිල්ලා මේ gradient එකේ m කියන එක පහළට ඇවිල්ලා m not එක උඩට එනවා. m කියන එක පහළට ඇවිල්ලා m not එක උඩට එනවා. So interchanging is not a problem. It's not a problem, right? You can interchange. there's no issue in that, right? But generally we don't, I mean දැන් මේ හොයන්න ඕන එක්කෙනා දැන් හිතන්න මේක ප්‍රශ්නේ වෙන්නේ මේකයි. දැන් ලේසියෙන් m කියන එක්කෙනා එනවා gradient එක වරක් m not multiply කරාම. දැන් ඔයා x and y වෙනස් කරොත් දැන් ඔයා හිතන්නකෝ you are changing y and as a result අර balance එක හදන්න ඔයා x වෙනස් කරනවා. ඔයා y එක පොඩ්ඩක් වෙනස් කරලා ඒ දැන් balance එක කැඩෙනවනේ. ඒ balance එක හදන්න ඔයා x වෙනස් කරලා හදනවා. එතකොට අර ඔයාගේ independent variable and dependent variable වෙනස් වෙනවා. හරිද? මේක මෙහාට ඇවිල්ලා මේක මෙහාට යනවා. එතකොට මේක උඩට මාරු වෙනවා. උඩට මාරු නම් right එන්නේ මෙහෙම. gradient is equal to m naught over m. එතකොට අර m සමානයි m naught over gradient. මෙතන මේක අමාරුයි guys, right? Like m naught is known as gradient. මේක බෙදුවොත් තමයි මේක හම්බෙන්නේ. So we don't prefer to divide, right? We usually prefer to multiply and get the answer. So like that is just a convenience problem, right? So other than that, there's no restriction, right? Like there's no restriction like you shouldn't change x, always our balance එක හදන්න ඕනේ y ගෙන් කියලා එහෙම restriction එකක් නැහැ. So our plan was to change x. I mean our plan was to take x as the independent variable and always y as a dependent variable. So because of that only, from the beginning itself, I said you guys, okay, x වෙනස් කරන්න නැතුව තියාගෙන balance එක හදන්න y වලින්. balance එක y වලින් හදන්න කියලා. right? එතකොට අර x වෙනස් කරලා balance එක හදන්න y වලින්. x independent or y dependent. I had a plan, right? So to go with that only, I just ask you not to do that. But there's no restriction, guys. Right? There's no restriction in some experiments. You might get the other way around, right? සමහර විට මේවා මාරු කරලා independent dependent variable වෙනස් කරලා දෙන්න පුළුවන්. So you have to be able to don't memorize these things and go with the concepts, right? I goes like don't confuse with that last statement. Like I hope that's slightly understood. There's no restriction, it's just the purpose of convenience, right? Okay, so the rest of the 2 points, important facts regarding the experiment, will be done on this Thursday. And I insist you guys to please make sure to complete the paper as soon as possible. Paper right? Please send the paper, right? Hurry. See you guys on the Thursday's class then, guys, right? Bye, guys. Good night.